So we've been talking about using standard deviation as kind of a spread, but let's get into that in a little bit more detail here. So when we have data that's symmetrical or approximately symmetrical, we consider that called a bell shape. You may have heard of the bell curve. That's what we're looking at here. And when we have this beautiful situation where it's approximately symmetrical, some neat things happen with standard deviation. When we have this bell curve, approximately 68% of the data will be within one standard deviation. Of the mean. That's a lot of the data. That's over half is within one standard deviation away, added and subtracted. Now, on top of that, 95% of the data will be two, I'm going to abbreviate, standard deviations from the mean. Wow, that's a lot. So almost all of the data is going to be within three. I mean, almost all of it. And technically, it's 99.7%, 99.7%. Almost all of the data will be three standard deviations from the mean. So what does it mean if you have something that's further than that? I mean, that's like really out there. That's kind of an outlier. It's something we really wouldn't want to see. So these numbers are really great to know. So let's look at this picture. So here's my mean in the middle. If I add the standard deviation and subtract one standard deviation, that's 68%. Now, if I add another standard deviation, subtract another standard deviation, that's 95% of the data. That's really just amazing. So let's look at this data. The following table presents the U.S. Census Bureau projection for the percentage of the population age 65 and older for each state and the District of Columbia. So to be able to use the empirical rule, first off, we need to make sure that the data is symmetrical. And then we're going to need to find the mean and the standard deviation. So we're going to talk about how to do all that. So the first thing I'm going to do is put all my data into the calculator. So we're going to enter the data in the calculator, enter the data. I'm going to pause the video and do it on the side so this won't take up forever because you really don't want to see me typing in a whole bunch of data. Okay, so I've entered all 51 data points into my L1. And so I want to look at the histogram for that. So to look at the histogram, that's a stat plot. It's a statistics plot. So I'm going to press second y equals. And notice how that plot one is highlighted. I'm in there and I want to turn it on. I can either make a scatter plot, a connected plot, like a time plot, or this option is a histogram. Now to make sure my window matches, I'm going to press zoom, and there's an option for zoom stat. What that's going to do is make my window match my data. So I'm going to press that, and let's look at what we have. So notice that the majority is in the middle, and if I kind of drew around it, I would have a nice bell. So it is bell-shaped. So now we can compute our one variable statistics. And the things I'm wanting to know the mean and the standard deviation. Now there's going to be two standard deviations that show up. So let me write down my mean first. I'm going to just do 13.249. And then this is the entire population. So this SX would be the sample standard deviation. And this weird little sigma, I've had some students call it the pregnant 6, is going to be my standard deviation. So I'm going to go 3 decimal places, 1.683. So what I want to think about is what's happening here. So if I were drawing this, Isabel, beautiful. All right, so right in the middle would be my mean. And technically that would actually be this mean because it's really the population. In the calculator, it's showing up as X bar, but this was coming from an entire population. I'm going to count out 3 standard deviations. 1, 2, 3, 1, 2, 3. So I'm going to add that standard deviation each time. So whoops, I typed in 1 too many times. 13.249 plus 1.683 gives me this value right here, 14.932. If I add the standard deviation again, I'm at 16.615. If I add it again, I'm at 18.298. Now I could go the other direction. I'm going to take that mean and subtract the standard deviation. Okay, so what this is telling me is that I can talk about this data as far as the empirical rule. And what that means is that 68% are between the percentage of the population age 65 or older. 68% of the states are between 11.566 and 14.932. 95% of the states have a percentage between 9.883 and 16.615. So here to here is 68%. Here to here is 95%. And then almost everyone, almost all, I mean 99.7%, that is almost everybody, would be between 8.2 and 18.298 or 18.3.